Hello and welcome to this solution video of paper 32 A-level mathematics. If you like this video, please share with your friends, give it a thumbs up and subscribe to Math United. Let's get started with question number 1 straight away. It says we need to draw the graph, sketch the graph of y. Sketch means it may not be an accurate one, but it should be a graph of y equal to absolute 4x minus 2. So if we draw a graph of 4x minus 2, that means minus 2 will be the y-intercept here, somewhere here, and 4x will be the gradient, something like this. Okay. So if this is the case, and it will go beyond minus 2, it will be something like this. However, because of the absolute, this negative part will not be negative. It will be reflected. So that means there will be no graph beyond this, only that the graph which was going down will now be reflected. So we will have a graph like this, which will be reflected part of what was going down. Okay. Now we need to, whenever we sketch a graph, even though it is not according to the scale, but we should always give our x-intercept, y-intercept and all that. So it was minus 2, which was the y-intercept earlier, right here somewhere, but it is reflected now. So this will, the y-intercept here will be plus 2 because it got reflected. What is the x-intercept? For x-intercept, just make y equal to 0. So if I say 0 equal to 4x minus 2, so 2 is equal to 4x. So x will be equal to 2 divided by 4. So that becomes half. So this particular point is half. That is the x-intercept. There will be an arrow here, and this is how the graph looks like. Okay. Now solve the inequality. 1 plus 3x is less than this, what we have drawn earlier. So let's do first graphically. And what we will draw 1 plus 3x graph, that means y equal to 1 plus 3x graph, and see where it is less than 4x minus 2. So 1 is the y-intercept, positive 1. So somewhere here, this will be the y-intercept, and the gradient is 3x. Keep in mind, this one is 4x, right? 4, gradient is 4 in this one. So from here, if I want to draw gradient 3, it will be little shallower than this. It is steep. The gradient of 3 will be little shallower. So that's why it will cross this line twice. So it will, suppose this is the graph. I will have to change it. This is starting from here. Okay, this is the graph of this y equal to 1 plus 3x. So 1 is the y-intercept. Okay, here 1 is the y-intercept, and the gradient of this part is 3. Okay, now if we use our graph and find this point and this point, in these 2 points, we want 1 plus 3x to be lesser than. That means this graph must be below the V-shaped graph we have. So it is below from this point onwards and this point backwards. Yes. And what are the x coordinates of these two? It is points of intersection. That's what we will find from the graph and find it. But because my graph does not have a proper scale, I will use the second method, which is algebraic. In this, what do? I will write this absolute, one's positive, one's negative. So it is 1 plus 3x is less than 4x minus 2, no change. But in second case, I will write 1 plus 3x is less than negative 4x plus 2. Because we do not know what is inside, is positive or negative, right? So let's see what it gives us. It will give us one of these 2 points. So 4x comes this way, so minus 4x plus 3x less than minus 2 minus 1. So minus x is less than minus 3, and both negative and negative cancel, but whenever we cancel a negative, this must change. So x is greater than 3, which most likely is this one, because the other one will be less than half. So this point we have x is 3 or greater than 3. That means this is our answer. X is greater than 3. This is one of the answers. Second answer, it will be minus 4x. When it comes here, it becomes 4x plus 3x less than 2 minus 1. Yeah, so 7x is less than 1, x is less than 1 over 7. So these are the two answers. This point of intersection is x equal to 1/7. This point of intersection x is 3. Once it is greater than 3, once it is less than 1 over 7, both are the right solutions. So we move on to next question, which is this. The parametric equation of a curve are this. Let me write this one properly because I may not have written it that one. So natural log of t to the power 2. Whole of this, there's a bracket around it. And the second one is y equal to e to the power 2 minus t square. This is the proper way of writing this one. For t is greater than 0. Find the gradient of the curve at the point where t is equal to e. So gradient m is nothing but dy over dx. For dy over dx, we need dy over dt first by chain rule. So dy over dt. That means we have to differentiate this one with respect to t. So e to the power 2 minus t square will be copied. That is how we differentiate e. Then further we have to multiply it by the differentiation of its exponent. So minus 2t, because differentiation of 2 is 0, so ignore it. 2 will come in front, so minus 2t is the differentiation of this. We usually don't leave this like this, so we will write minus 2t first, and then we will write 2 minus t square here. This is dy over dt. Now secondly, we need dx over dt. Differentiating x with respect to t. So 2 will come in front. Okay, and natural log t. The exponent will go down by 1, so 2 minus 1 is 1, so we'll leave it like this. But further, we have to differentiate what is inside the bracket, and differentiation of ln t is 1 over t. So I can write this as 2 over t natural log t. Now I want to find dy over dx, which can be written as dy over dt multiplied by dt over dx. dy over dt is known to us, minus 2 t e to the power 2 minus t square multiplied by dt over dx. We have dx over dt here, that means reciprocal of this, which will be t will become numerator 2 and ln t will become denominator. Can we cancel something? Yes, 2 and 2 can cancel. Okay, let me stabilize this. Okay, t and t can multiply, so it becomes t square, and we have negative this one already here. Okay, e to the power 2 minus t square, and what is left here, I can write this ln t square. I am making this, oh, this 2 was already cancelled out, so there is no need to write that. So ln t, this 2 and this minus 2 was cancelled out. Okay, this is it. But this is not final. They're saying where t is equal to e, in place of t we will write e now, and let's see what we get when t is equal to e. So t will be replaced by e, minus e square e2 minus t square over ln e. Ln e is 1, so that means your denominator can be ignored because anything divided by 1 is the thing itself. So I will not write the denominator anymore because they have same base e, so these two will add up. So minus e to the power 2 plus 2 minus e square, because t is again replaced by v. With that I did not do here. So what do we get? Minus e to the power 4 minus e square. This is the gradient. We have not been asked to give exact, but they have said simplifying your answer, so that's fine. Simplification is over, no need to convert to decimals. Okay, question number 3 says what? The polynomial 2x cube, so let's say px, this was the name they are giving, px, 2x cube plus ax square minus 11x plus b. It is given that it is divisible by 2x minus 1. So divisible by 2x minus 1. That means if 2x minus 1 is 0, because if one of the factors is 0, the whole polynomial will become 0, right? Which gives us 2x equal to 1, x equal to half. Px will be 0 if 2x minus 1 is 0. So I will substitute this x in the polynomial. So p half will be 2 half cube plus a half square minus 11 half plus b, and this is equal to 0 because the polynomial has to be 0 because its factor is 0. So what do we get here? 1 over 8, so it becomes 2 over 8. So I can write 1 over 4 here. This will be 1 over 4a. This will become 11 over 2 plus b is equal to 0. Can I make it an equation? Yes. Let's multiply the whole equation by 4 so that these denominators of 4 are gone. So 4 multiplied by 1/4 is 1. 1/4 times 4 is again 1, so just a minus 2 will cancel out with 4, so we'll left with 2. So 11 over 2 times 4 will be 22 plus 4b equal to 0. So this gives us a plus 4b equal to minus 21. Yeah, this way. So when it comes to the right side, 21. Equation number 1. Okay, let's form equation number 2. They said the remainder is 12 when it is divided by x plus 1. So by remainder theorem, x plus 1 will give us x equal to minus 1, but it is not a factor, so it will not be equal to 0. Px will be equal to 12 if x is equal to minus 1. So let's write p minus 1 is equal to 2 to the power minus 1 cube plus a minus 1 square minus 11 minus 1 plus b will be equal to 12. So this becomes minus 2. This becomes plus 1. So a, just a, plus 11 plus b equal to 12. So a plus b remain here, and 12, this will be how much? 9, positive 9. So it will become minus 9 on the other side. So a plus b is equal to 3. This is equation number 2, and I want to use elimination method by writing, multiplying this, just write it, a plus b equal to 3, and subtract the whole equation from the equation number 1. A minus a is 0, gone. 4 minus 1, 3b equal to 21 minus 3, 18. B comes out to be 18 over 3, which is 6 have they said? Okay, just find A, B. So 6 is B. What about A? So A plus 6 is equal to 3 because 6 is the B we got here. So A is 3 minus 6. A is minus 3. Got A, got B. Moving on. For A part. Okay. On a sketch of an Argand diagram, shade the region where points represent complex number Z, satisfying the inequalities this. Okay. Okay, so I have drawn here some axes. This is the real part. This is the imaginary part of the complex number Z. First of all, this whole expression should be written like this. The magnitude of Z with respect to 4 plus 3i is less than equal to 2. What did I do? I separated this Z from minus 4 minus 3i. Whenever we separate, we must write a minus because Z is in reference with this. If I open up, I get back this thing. So 4 plus 3i becomes our reference from where Z is 2 units or less away. So what will I do? I will draw a circle where first real part is 4 and imaginary part is 3. So let me make some scale here. 1, 2, 3 and 4. And there will be 3 units in this direction. 1, 2, 3. So this becomes the center of the circle I am going to draw. Okay, and that circle will have a radius of 2 units. So let me try to draw it here. So from 3 it will reach 1 and from 4 it will reach 2. So I think I need to this. It has reached little smaller and little smaller there. Okay, this is the one where the center is 4 plus 3i, this center, okay, and this radius is 2. Okay, so on a sketch on Argand, shade the region. I have this already shaded inside because it's less than and equal to 2. This one, okay, whose points represent complex number Z satisfying the inequality this, and there is one real part, which is real part of Z is less than 3. Okay, this is what I've got. This is the line where real part is 3, right? But we want less than or equal to 3. That means we have to shade the smaller than this part, right? Less than 3. What part is common in these, this circle and this segment, right? So this will be our answer, because they say on a sketch of Argand diagram represent shade the region. This is the region. Shall I use a different color? Let me try. Okay, this is the answer. This and this part is the part which is satisfying both the inequalities. Okay, find the greatest value of argument of Z. Okay, Z. So argument of Z like this. Argument of Z can be written as Z minus 0 with reference to 0. That means from origin the Z's argument should be greatest. So let me draw a line and we'll decide together where is it greatest. So the gradient here, look at this. Gradient is this small angle. So this is not greatest. And I will pass through circle and this shaded area. This is the smallest where it is touching that shaded area, right? Now we'll keep on increasing it, and this here, it gives us the greatest angle in the shaded area. Let me show you again how. So this is the point where it is touching this shaded area and giving us the maximum greatest value of argument. So we have to find this angle basically. This angle will be the argument of z, the greatest. If somehow I find this angle is already known to me. The argument of z is 4 plus 3i. So argument of 4 plus 3i, that angle plus this small angle. If I find this angle also, I'll get that greatest argument. So first let me find this one, and this will be what? Tan inverse. If this is say alpha, so tan inverse alpha will be tan inverse opposite, which is this, how much? 3 over 4. This will be this angle. How about this angle? Okay, let's call this angle beta. So beta, this was alpha, beta will be, we know this is 90 degree. Why? Because the tangent and radius always make 90-degree angle, and we know the length of this particular side is 2 units, that because it was less than 2 units, so this is 2. So let me redraw this here somewhere here. 90-degree, this is 2 units, and this is 4 plus 3i, its magnitude will be 4 square plus 3 square, which is 16 plus 9, 25, square root will be 5. So this is 5 and this is 2. I can find this angle beta here, which will be, this is opposite and this is hypotenuse. So sine inverse opposite, which is 2 over this 5, and thus alpha plus beta is the greatest argument. Tan inverse 3/4 plus sine inverse 2/5 comes out to be 1.0550 radians. So 3 segment figures will be 1.05 radians. Okay, let's go to the next question. Number 5. Find the exact value of this integration. If we notice, the degree of the denominator is 2 and degree of numerator is also 2. So if they are equal, we should first divide before proceeding. So x square plus 4 divides x square plus x. Yeah, that's what we will get when we open this bracket, x square plus x. Okay, so x square and x square, so I'll multiply it by 1 so that we get what? X square plus 4. If we subtract, this cancels out and here I get x minus 4. So the quotient is 1. So this particular question will change to 0 to 6 1 dx. That is the quotient. Then plus a new fraction or rational expression will be x minus 4, which is the remainder here, divided by x square plus 4. Furthermore, we can also divide this. Let me write dx. One I can ignore now. I can break this also into 2 parts. So I can write x over x square plus 4 dx minus 4, let me write 4 outside, 1 over x square plus 4 dx. So I hope you understand. I broke this numerator into 2 parts. How this will help me? So in integration of dx is x. So let me straight away write what I get here. X from 0 to 6. Since this is a definite integral, so I'm not writing plus c for everyone. Okay, so plus, if I somehow write 2 here and half here. This 2x is the differentiation of x square plus 4, right? Differentiation of x square is 2x and differentiation of 4 is 0, so 2x. So it becomes du over u format. The differentiation of the denominator is the numerator, and in that case ln u becomes the integration. So in this case it will be half and natural log of x square plus 4. This one is done. Minus 4, and we have to integrate this. For that we have to do some legwork, and that I'm going to do here separately. So my integration I want to do is 1 over x square plus 4. Let's assume x is equal to 2 tan theta. Why 2? You will understand very soon. Because if I square x, it will be 2 tan theta square as well. So x square becomes 4 tan square theta. So in place of this x square, I can write 4 tan square theta, and we already had a 4 after that. What about this? We had a dx here. So let me differentiate this. How? Dx over d theta. I'm differentiating it with respect to theta. 2 will remain 2. Differentiation of tan theta is secant square theta. And this d theta can, from here I can cross multiply here, it becomes 2 secant square d theta, which is equivalent to dx. And this dx will be replaced by its equivalent, 2 secant square theta d theta. So let me cancel this 2 and 4 will be root 2 here, so I'll take that half outside, and secant square theta d theta here, and this rather I should not have cancelled yet as of now, so I will undo this what I've done. So what I'm going to do, I'm going to write 2 secant square theta d theta as it is, and take 4 common out of this. Tan square theta will be left. Both of them have 4, right? That's why I assumed x equal to 2 tan theta, so that I can take this 4 common. Okay, sorry, I have to write 1 here. Okay, tan square theta plus 1 is secant square theta. That means this and this can cancel out now, and I can cancel 2 and 4 now. So it becomes half and just d theta here. What is d theta? Integration of d theta. It will be half theta, just like this. Dx is integration of x. Integration of d theta will be theta. But we don't know theta yet. So let me take this equation again, and can I write this one as x over 2 equal to tan theta? That means according to this, theta will be tan inverse x over 2. And this is what I'm going to write here, which is half tan inverse x over 2. So I got my third part also. Half I will write outside because minus 4 is already there. So I'll write divided by 2 tan inverse x over 2. 0 to 6. And this is also 0 to 6. And now I will just substitute 6. So it will be 6 minus 0 in this, plus half natural log 6 square plus 4 minus natural log 0 square plus 4, and this one, this can cancel, minus 2 tan inverse x is 6 over 2 minus tan inverse 0 over 2. Okay, 6 minus 0 is 6 plus half. This will be how much? 36 plus 4, 40. So natural log, because they are subtracting, I'm dividing what is the content. So 40 I got from here and just 4 from here. So I'll divide the content. Okay, that's it. Minus 2 tan inverse 3 and tan inverse 0. It will be 0, right? Tan inverse 0 is 0, so no need to write that one. So I think we are there. They're saying exact value, so that means decimal is not acceptable. So half, this will cancel, and I can bring this half as a power of 10. So it will be natural log square root 10, because power half is same as square root. And minus 2 tan inverse 3. This is the exact value of the integration. All right, moving on to the next one. Again, sketch. By sketching a suitable pair of graphs, show that the equation cot x equal to 2 minus cos x has one root in the interval 0 to pi by 2. Okay, first of all, we should know how the cot x graph looks like. So cot x, let me first draw some axis. So 0 to half pi is a very small range. Okay, so for tan, this pi by 2 is an asymptote, but for a cot graph, it is not an asymptote. This y-axis is the asymptote, and it's a decreasing graph. From here it comes like this, and it goes something like this to pi. This is pi by 2. Okay, but since they are asking us to only draw up to pi by 2, half pi, that means I will ignore this one. This is the only graph I have, and this is 0, this one is 0, and this one is pi by 2. This is how a chord graph looks like. Suppose you don't know how a graph looks like, so you can make a table. Make a table of say 0, and then pi by 3, pi by 4, pi by 3, pi by 6, sorry, pi by 6 here, and pi by 3 here, and pi by 2. You will get some values. Just put cot is 1 over tan. Okay, so for this value you will write 1 over tan 0. For this value you will write 1 over tan pi by 6, and this is how you'll get, and you'll get this kind of, I'm sure about the shape of the graph, that's why I'm straight away drawing this. Okay, now we need to know 2 minus cos x. First of all, we should know how the graph of minus cos x, y equal to minus cos x look like. Y equal to minus cos x. So cos cannot be below minus 1 and above 1. Let's say this is minus 1, this is 1. Okay, since y equal to minus cos x is a reflection of cos x, that means it starts from below here and then it goes up to this one. So this is how it should look like, something like this. But this is not enough. We need to have plus 2 also. So minus cos x graph I just showed you, I have to add plus 2 to this. So the minus 1 plus 2 will be 1. So the graph which was going like this will now go from here like this, so something like this. So we can see that there is only one point of intersection between this graph and this graph. So to summarize, I drew a graph of y of cot x, and this is what you should do all the time if you want to show graphically. Y equal to minus, so right hand side one equation function, on left hand side one equation of a function, so they cross here. So we can, by sketching, we have shown that there is only one solution. One root means one solution, one point of intersection of the two. What about next? Show by calculation the root lies between 0.6 and 0.8. So whenever you have such a situation, isolate one of the axes. So there is one more part to this, I think, where they have written tan inverse. That means cot is to be isolated. Okay, what will I do? Can I say that 1 over tan x, yeah, because cot x is 1 over tan x, is equal to 2 minus cos x, correct? If I cross multiply, this will go there and these may come here. So it will be tan x equal to 1 over 2 minus cos x, right? And to isolate this x, what will I write? X equal to tan inverse 1 over 2 minus cos x. Now, they are asking us to show that the solution of this equation lies between 0.6 and 0.8. So what will I do? I will write x is 0.6. I'll substitute 0.6 once. So you will see that 0.6 will not be exactly equal to tan inverse if I substitute x here also. Just see what happens. 1 over 2 minus cos 0.6, and actually when they say this is cannot be a degrees angle, it will be a radian. So let me put this in my calculator. It came out to be 0.705. So 0.6 is less than 0.705. They are not equal. So if I substitute 0.8 now, it has to be greater than whatever we get here. That will prove that the inequality is changing between 0.6 and 0.8. That means equality is between them. Okay, so I will just put in place of 0.6, I will put 0.8 and see what I'm getting. I'm getting 0.6544. See, 0.6544. So change in inequality is a sign of equality, which we can say the root between 0.6 and 0.8. Okay, this is how we can show. All right, what is the next part? Use this iterative formula. So exactly same what I wrote here, x equal to tan inverse this. So they have made iterative formula out of this. So they have written n plus 1 here, and this has become n, and we have to show iterations. That's what this question is about. So whenever we have such a situation, we take a number. We said that the root is between 0.6 to 0.8. So in between we have 0.7. So we will start with x1 equal to 0.7. That means this x1 will be 0.7. So x1 plus 1, x2 will be tan inverse 1 over 2 minus cos 0.7. So I substituted x1 in here, so I got x2. For x3, I will substitute whatever answer I get, I will do it here. I'm fast forwarding this video so that you understand what I'm trying to say. So x3 . So I got my answer. I think I'm writing 4 decimal places every time I wrote, and if I round it off, it becomes 0.681. Okay, how many places we on? 2 decimal places, so 68 is the only one. This one is 0.69. This will be 0.68, and this is also 0.68. So 2 consecutive rounding offs are exactly same. So our answer is the root is 0.68. Okay, question number 7. By expressing 3 theta as 2 theta plus theta, so we have to express 3 theta equal to 2 theta plus theta, prove this identity. So in place of this 3 theta, I will write cos theta, 2 theta plus theta. Okay, so how can I get okay, I want theta only, not this 2 theta also has to go. So we can use the identity cos A plus B. The identity is cos A cos B minus sin A sin B. So it will be cos 2 theta cos theta minus sin 2 theta sin theta. Okay, cos 2 theta, we want cos cube theta here, right? So we can use the one which is 2 cos square theta minus 1. This is another identity. If cos 2a is there, it is equal to 2 cos square theta minus 1. Then we have cos theta outside this one. Minus sin 2 theta can also be written as 2 sin theta cos theta. And sin theta is extra, so sin theta will be written here more. So if I open this, it becomes what? 2 cos square times cos. It will be 2 cos cube theta minus cos theta. When I open this, now sine and sine is sine square minus 2 sine square theta cos theta. So because I don't want any sine, so sine square theta can be written as 1 minus cos square theta. So it is 2 cos cube theta remains so because we want a cube already, minus cos theta minus 2 in place of sine square theta. I will write 1 minus cos square theta. So every sine theta is gone. Rather, yeah, gone. Okay, so 2 cos cube theta minus cos theta minus 2 times 1 is 2, and that times cos theta will be 2 cos theta. 2 times cos square theta is positive. These two are negative, so it will become positive 2 cos square theta, and again cos theta, it will become 2 cos cube theta. So 2 cos cube theta plus 2 cos cube theta is equal to 4 cos cube theta. Minus cos and minus 2 cos becomes minus 3 cos theta. This is RHS proved. Okay, what else they're asking? Hence, solve this equation. So cos theta, 3 theta is this is what we got. So in place of this, we can write 4 cos cube theta minus 3 cos theta. Then we have cos theta, cos 2 theta, cos theta, and cos 2 theta again I will write as the one I used earlier, 2 cos square theta minus 1. And let me bring this cos square also to the left side. So minus cos square theta is equal to, nothing is left here now. So everything is cos. 4 cos cube theta minus 3 cos theta. Cos cube and this, sorry, cos and cos square will become cos cube again. So plus 2 cos cube theta minus cos theta times minus 1 will be cos theta minus cos square theta. Everything is cos here. So let's see, 4 here and 2 here becomes 6 cos cube theta, and then we have square minus cos square theta, this alone. But this minus 3 and this minus cos theta will become minus 4 cos theta equal to 0. Now all of 3 of them have cos theta, so let's take cos theta common. what is left? 6 cos square theta minus cos theta minus 4 equal to 0. These two are multiplying to give us 0. That means one of them is 0. We don't know which one. So we'll say that this gives us cos theta is equal to 0, and this one gives us 6 cos square theta minus cos theta minus 4 equal to 0. That becomes theta equal to cos inverse 0 here, and they have given us that theta should be between 0 and 180 degrees. So if I draw a cos graph, for 0 you should always take the help of graph. Cos looks like this. So this is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. Or in degrees, it is 0, 90, 180, 270, and 360. So between 0 and 180, there's only one place where it is 0. So cos inverse 0 gives us 90 degrees, because they are asking in degrees, so we'll write in degrees. Okay. Now this one, we have a quadratic format here. So can I split the middle term? Let's assume cos theta equal to t in this case. So 6t square minus t minus 4 equal to 0, and we cannot split the middle term with 24. Yeah. So that means we'll have to use quadratic formula for this. Okay. So I'll use minus 1, which is minus b, plus minus 1 square minus 4 times AC over 2 times 6. So it is 1 plus minus 1, and this will be how much? 16 times 6, 96, 97, square root 97 over 12. Okay, so theta, because cos theta is this, so theta will be cos inverse of 1 plus square root 97 over 12 once, and then we'll see the next one. First let me check this one. Okay, this was second one. Let me write second one also. So theta, second theta, I will write somewhere far. Theta is equal to cos inverse 1 minus square root 97 over 12. We know that this will be positive, and that means because our domain given is 0 to 180, this will be in first quadrant. If I use my calculator to find this, I will get answer in first quadrant, which is not possible in second quadrant because it's positive. So whatever answer I get is the answer. Let me use my calculator for this. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting is 25.3 in this case, and 137.5 degrees in this case, and it cannot be an acute angle, so these straight away are the right answers. It is given that 2 plus 3ai over this is equal to this, where lambda and a are real constants. Okay, so that this equation is valid. Okay, so 2 plus 3ai over a plus 2i. Let's rationalize this. Are we getting something in terms of this? A square plus 4. No, we are not getting. So let's do something else. This was the equation. Let's cross multiply. So 2 plus 3ai is equal to lambda 2 minus I a plus 2i. So 2 plus 3ai remains same, lambda remains same, and let's multiply this. 2 times a, 2a, 2 times 2i minus ai minus 2i square. Okay, it has a real part and an imaginary part. Let's keep it like this, but here we can separate. This is real part, and this will also become real part because minus 2i square will be plus 2. So this is gone. In place of this is plus 2. So 2a plus 2. What about imaginary part? Plus lambda will remain lambda because lambda is with all of them. This imaginary part 4. This is minus a and I. So compare real and imaginary parts. So 2 is the real part on the here, this part, and what is 2a plus 2? Rather, let's take 2 common out of these two, so a plus 1 inside here, and we have lambda also. Okay, what about second one? 3a equal to, I'm not writing I because both have i's, so lambda 4 minus a, and we are somewhere now. Let's call it equation number 1, equation number 2, and let's divide equation number 2 by equation number 1 because it's a little bigger. So 3a left side divided by left side of 1 will be lambda 4 minus a over lambda 2 a plus 1 lambda. So we can see something is getting cancelled here. Lambda and lambda cancel. This 2 can cancel with this 2. Okay, so a plus 1 is the only denominator left which we can cross multiply here. So let me finish it here. 3a multiplied by a plus 1 equal to 4 minus a. Nothing is left. Okay, so this becomes 3a square plus 3a equal to 4 minus a. So 3a square plus 3a, stay here, a goes there and 4 also comes, they change their signs. So plus 4a minus 4 equal to 0. This is what they asked us to show. Okay, hence let's keep it visible. Hence find the possible values of a. So we'll just solve this one. So our b part starts here. We can split the middle term, right? 4 times 3 is 12. So 6 times 2 is also 12. 3a square plus 6a minus 2a minus 4 equal to 0. I splitted this middle term. So 3a is common here. A plus 2 in this, minus 2 is common here, a plus 2. So the two factors we get a plus 2 and 3a minus 2 equal to 0. So this one gives us a plus 2 equal to 0. So finally a equal to minus 2. What about this one? 3a minus 2 is equal to 0. 3a is equal to 2, so a is 2 over 3. Got a. However, they are also asking us to find lambda, corresponding value of lambda. That means for minus 2, what is lambda? And we can use one of the equations. Let me use this one. Okay, equation number 1. So 2 equal to, though I can cancel them also, but I'm just keep them. A is here minus 2 plus 1. when a is minus 2 lambda. So minus 1, so 2 equal to minus 2 lambda. Lambda is 2 divided by minus 2, which is minus 1. This is lambda's first value. Second, 2 equal to 2/3 plus 1 second and lambda. 2/3 is this one. Second value of a I've kept here, so 2 equal to 5/3. So 10 over 3 lambda. So lambda will be 2 times 3 divided by 10. So got it. Lambda is 3/5 for when a is 2/3. Got all 4 values. Shall we go ahead? Yes. Okay. The diagram shows the curve y equal to this for 0 to pi. Okay, 0 to pi has a maximum at m. Yes, where x is equal to a. The x coordinate is a. The shaded region between them is r. Okay. Find the value of a correct to 2 decimal places. Okay, so in decimal we have to give the answer. So since this is a turning point, the gradient of the tangent will be 0, and gradient of tangent is nothing. Let me write here. Is dy over dx. That means I have to differentiate this equation. I'll get dy over dx. So dy over dx equal to sin x and cos 2x are multiplying. That means we'll use product rule. So it will be sin x remains sin x, but cos 2x is differentiated. Then cos 2x remains same, but sin x is differentiated. So it will be sin x, and this will be minus 2 sin 2x. So let me write here minus 2 in starting and then sin 2x here. Okay. Cos 2x remains cos 2x, and sin x will be cos x. So if this 2 was not there, it would be simply cos a plus b identity, but there we have 2 here. So that means we have to do something more. So what can we do? Because we want to find the gradient, right? And gradient is horizontal. The horizontal gradient is 0. That means this is equal to 0. So this becomes an equation and nothing is common. That means, like one of the previous questions, we will have to convert it to just cos. So sin x remains sin x. Sin 2x can be written as 2 sin x cos x. Now you might be thinking that we still have sin x, but this is sin square x, which can become cos square x later on. So here also I will put cos square x. Okay. Or let's leave it sin only, because cos x will be common here. Alright. So I'll use the identity, this one, cos 2a equal to 1 minus 2 sin square a. So this also has sin square, so it will be helpful. 1 minus 2 sin square x, and then we have cos x. Let's take cos x common, if that is equal to 0, right? Cos x. Okay, this is out. So we are left with minus 4 sin square x. Here cos x is out, so 1 minus 2 sin square x equal to 0. So cos x equal to 1, not equal to, here it will be minus 4 and minus 2, both of them are sine square, so it becomes 6 sine square x equal to 0. Alright, so if both are multiplying to 0, that means either this is equal to 0, cos x equal to 0, or 1 minus 6 sine square x equal to 0. This gives us x equal to cos inverse 0, and we can see that x is 0 here, right? Cos inverse 0, sorry, x is equal to pi by 2 in this case, because cos pi by 2 is 0 and pi by 2 is somewhere in between. So that means this is not our answer. It cannot be a. It is not half of this pi. Let's see here. 1 equal to 6 sine square x, that means 1 over 6 equal to sine square x. Square root both sides, we get plus and minus 1 over 6. Let me complete here. So sine x equal to plus or minus square root 1 over 6. Since sine is positive in first quadrant only, right, because this is first quadrant, pi by 2 is somewhere here, so it is a is less than pi by 2, that means this negative has to be ignored because we can't have answer in second quadrant. So this is the answer, which will be x equal to sine inverse square root 1 over 6. Alright, so we can put this in a calculator, and because it's pi here, so we'll get our answer in radians. Let me use my calculator. By the time I'm doing this, I'll request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 0.42 radians. Okay, there's no need to write radians. Every angle is in radians unless written degrees. 2 decimal places, 2 decimal places. Okay. Find the exact area of R. That means we need these two values also. Yes. So that, because this area will be positive for sure, this will be positive. However, this will be negative. And this starts from this point to this point. So I have to find next two x-intercepts after 0. So for that, I need to make main equation equal to 0. Let me do it here. This sine x cos 2x equal to 0. So this gives me sine x equal to 0 or cos 2x equal to 0. This gives me x equal to sine inverse 0, which is 0. Yeah. So we got this point, but it is of no use. Let's see what it gives us. 2x equal to cos inverse 0. So if I draw graph of original cos, this is not cos, okay, original cos will be somewhere here. So I get 0 cos 0 at these two angles. This is pi by 2. This is 3 pi by 2. So I will write those here. So one answer will be 2x equal to pi by 2. And the second one will be 2x equal to 3 pi by 2. So what does this give us? X equal to pi by 4 and x equal to 3 pi by 4. So this one, the second one is pi by 4. Third one is 3 pi by 4. So these two become our limits. Obviously our area will be negative because it's below x-axis. No problem, we will just find its absolute value. Okay, so we'll integrate sine x cos 2x. This is the original function, and we will find its value from pi by 2 to pi by 4 over 3 pi by 4 dx. Can we somehow do this. Yeah, we can. So we will again change this cos 2x here. So pi by 4, 3 pi by 4, sin x remains sin x. So what do I change here so that one of them becomes the differentiation of the other? So I will do cos here. So the sin x becomes its differentiation. So cos 2a is 2 cos square a minus 1. This is what I will use here. So 2 cos square x. Now when I will do this, you will understand what is my planning. So sin x multiplies with this. So this becomes our first part. 2 I can take out. Sin x cos square x dx is the first one minus sin x dx becomes the second part. Let's assume cos x equal to t. So let t equal to cos x. So if I differentiate, dt over dx will be what? Minus sin x. So under dt equal to minus sin x dx. Yeah, there is no minus here. So I'll put a minus forcibly here and minus outside, it becomes positive again. So sin x dx becomes dt. And cos square x will become t square because t is cos x, so it will become t square. And minus remains minus. This minus will be outside. This minus has been part of this. So what is the integration of t square? Minus t cube over 3 plus c, right? So we can write minus, and t was cos, over 3 plus c. This is what I will write here. So it is integrated now. 2 was outside and 3 is here, so 2 over 3 minus 2 over 3 cos cube x. This becomes the integration of this, and let's not close it here because we know that the integration of sin x is minus cos x, so it becomes plus cos x plus c. So pi by 4 and 3 pi by 4. So let's substitute. Minus 2 over 3 cos cube 3 pi by 4, right, plus cos 3 pi by 4. Usually people ignore c, but I usually write it because it can't be ignored. It is part of the equation. Ultimately it will get cancelled out, that's okay, but still we should write it. Minus 2 over 3 was multiplying only with this, so cos cube pi over 4 plus cos pi over 4 plus c. So this cancels out with this c. And now we can use our calculator to evaluate rest of them. By the time I do this, I would request you to like this video, share with your friends. I think this is the first video on YouTube as a solution video, so they will get benefited, and subscribe to Math United. Thank you very much. So what I got from this part is minus square root 2 over 3 minus, and what I got from this part is positive square root 2 over 3, but it becomes negative because of this negative. It comes out to be minus 2 square root 2 over 3, but we'll have to absolute it. So area R will be the positive version of this because it's below x-axis, that's why it came out to be negative. We will write 2 square root 2 over 3, and that's the solution. Let's move on to the next part, or next question rather, question number 10. The equations of the lines L and M are given this way, where C is a positive constant. Okay, it is given that the angle between them is 60 degrees. Find the value of C. So the angle is decided by the direction not by the points. So this is direction vector, this is a direction vector. The angle between them is 60 degrees. That's what they're saying. So we'll find C according to this. So we know that A dot B is magnitude of A multiplied by magnitude of B cos theta, where theta is the angle between them. So this gives us cos theta equal to A B divided by absolute A and absolute B, which is theta is equal to cos inverse A dot B over absolute A absolute B. So theta is given as 60 degrees, and we'll convert our calculator to degrees, because in the previous question it was radians. Cos inverse, okay, A dot B. So this 112 dot minus 24C divided by magnitude of this one, which will be 1 square plus 1 square plus 2 square multiplied by magnitude of this one, which is minus 2 square plus 4 square plus C square. So 60 equal to cos inverse, dot product is when x multiplies with x, y multiplies with y, and they are added. So 1 multiplied by minus 2 is minus 2, plus 1 multiplied by 4 is 4, plus 2 multiplied by C. This comes out to be 1 plus 1 plus 4, square root 6. And this is 4 plus 16 plus C squared. 4 plus 16 plus C square. Let's try to go here. 60 is equal to cos inverse, okay, minus 2 plus 2. Rather, why I'm using cos inverse? Let me get rid of cos inverse. So it will become cos 60 equal to minus 2 plus 4 is 2 plus 2C. Here it will be square root 6. Let's write everything inside square root. So 6 multiplies with this one, 20 plus C square. So I hope you understand the mathematical rule that when two square roots are multiplying, both of them can multiply inside a square root. So cos 60 is half, and I can take, okay, let's not take common. Let's leave it 2 plus 2C over 120 plus 6C square. Now we have to find the value of C, so we have to square both sides so that this square root is taken care of. So 1 over 4 equal to, if I square 2 plus 2C, I will use this identity. A plus B whole square is A square plus B square plus 2AB. So A square plus B square, not B, I actually wrote B, plus 2AB over square and square root cancel out, so it will just remain 120 plus 6 square. That was our aim, so that this square root gets rid of. So this goes there, 120 plus 6C square equal to, this 4 will multiply with everyone here. So 4 multiplied by 4 is 16. 4 multiplied by 4C square, not 2C square, 4C square will be 16C square. And 4 multiplied with this 8C. So 8 times 4, 32C. So let's bring everything to here, because 16 is bigger than 6. So 0 equal to 16 minus 6, 10C square. Okay, 32C is alone, so plus 32C. And 120 comes here, becomes minus 120, so it will become minus 104. Okay, so I can use my calculator or splitting the middle term. First of all, let me make this easier. So 5c square, I'm dividing the whole square by 2, so whole equation, so it becomes easy for me. Okay, 52 times 5 will be 260, and 260 is 26 and 10. I am doing it mentally. Please use your calculator if you know how to solve such equations. I'm splitting the middle term manually. So 5c square equal to 26c minus 10c minus 52. So 5c not common, not 5c. C is the only thing common. 5c plus 26 minus 2 is common here, so 5c plus 26. Okay, so 0 equal to c minus 2, 5c plus 26. So this gives me c minus 2 equal to 0, which is c equal to 2. This gives 5c plus 26 equal to 0. 5c equal to negative 26, c equal to negative 26 over 5. In our question, they had clearly said this. C is a positive constant. That means I cannot take this answer, reject this one. C equal to 2 is the answer. Okay, B part. Show that the length of perpendicular from 6 minus 3, 6 is square root 11, and distance to which one? Length of the perpendicular from this to L. So let's say that this is 6 minus 3, 6 point. Okay, and this is the line L. The angle between them is 90 degree. So we have to show that the distance, this length is square root 11. So first let's see what was the equation of L. L is this one. 3 minus 2, 1. L was R is such that 3 minus 2, 1 plus some parameter lambda 112. Lambda 112. So if they are perpendicular, the direction vector of this line, dot direction vector of this line, let's call it, have they given any point? They have not. So let me call it A, let me call it B. So AB is a vector, its dot product with this direction 112 will be equal to 0 because they are perpendicular. So if I somehow find vector AB, that will be enough. So for finding this direction vector AB, I need the coordinates of B. Yeah, but we know that coordinate B is lying on L. That means this particular equation applies to B as well. So let's say the coordinates of this are M, N and Q. Since M is on line L, it will obey this equation. So M will become 3 plus lambda, because that's the x coordinate, 3 plus lambda times 1. N will be minus 2 plus lambda, and Q will be 1 plus 2 lambda. Now we need vector AB. Vector AB will be 1 end minus the other end will give us AB. Since 6 looks bigger number, so I'll do that. It doesn't matter because angle remains 90 degrees still. So 6 minus this coordinate M, which is 3 plus lambda, will become the x component of the direction vector. Similarly, we have minus 3 minus minus 2 plus lambda. And then we have 6 minus 1 plus 2 lambda. Let's simplify this to get 1 in terms of lambda. So 6 minus 3 is 3, and minus lambda will make this minus lambda, this minus sign. This is minus 3, so minus 3 plus 2 will be minus 1, and minus plus minus lambda. Okay, 6 minus 1 is 5, and minus 2 lambda. This becomes vector AB, and now we have to find dot product with 1, 1, 2. So the vector is 3 minus lambda, minus 1 minus lambda, 5 minus 2 lambda dot 1, 1, 2, and it has to be equal to 0. Again, for dot product, we'll have to multiply x component with x component. So 3 minus lambda, when we multiply 3 minus lambda with 1, then we'll have minus 1 minus lambda when we multiply these two, and it will be plus 10 minus 4 lambda equal to 0. So let's see what do we get here in number. 3 minus 1 is 2, 2 plus 10 is 12. Minus lambda is minus 2 lambda, and minus 4 lambda becomes minus 6 lambda equal to 0. 12 equal to 6 lambda, lambda will be 12 over 6 equal to 2. So we got our coordinates for M and Q now. We can substitute lambda equal to 2 here and we get it. 3 plus 2, 5. Minus 2 plus 2, 0. And 1 plus 4, 5. 5, 0, 5. Positive? Yes. In all cases positive. So 5, 0, 5. Now our question was to find the length of the perpendicular. That means we have to find the length of vector AB. Okay, and we'll use distance formula for this. So 6 minus 5 square. So x1 minus x2 square, y1 minus y2 square plus z1 minus z2 square. 1 square is 1, minus 3 is 9, and 1 square is again 1, and definitely which is square root 11. This is what they were asking us to show, minus square root 11. That's it. Okay, question number 11. The variables x and y satisfy the differential equation. This one. Okay, it is given that x is equal to 1 when y is equal to 1. Okay, solve the differential equation to obtain the expression for y in terms of x. We will separate these first. So x square dy over dx remains on one side, and minus y square minus y go to the other side. Now dx has to be with x and y has to be with y. So what will we do? I'll bring this dx here and bring these y squares and minus y here, so that they are, and this x square also go to the other side. So dy remains here, only dy, and we get minus y square minus y with it. Dx was here and x square becomes denominator. So now x is with x, y is with y. So can I take minus y common out of this? So 1 over minus y and y plus 1. And I'm separating dy here. This is x to the power minus 2 dx. This is how we can write them. And we integrate both sides. This is easy. This will take some time. So let's use partial fraction for this part. 1 over minus y and y plus 1. Let's assume this is equal to a over y, and this minus I can give here so that we get rid of negative. So we can write a numerator also, y plus b y plus 1 went out. Okay, so since denominator will be the same, so minus 1 will be equal to a y plus 1 and b y. We do not write denominator because they'll be same. If I multiply these two, denominators will be same, so we just take care of the numerators. So minus 1 equal to ay plus a plus by. Okay, so let's take y common. So minus 1 equal to a plus b y and plus a. So now there is no y here, so I can write 0y and compare. So first I will compare constant minus 1 and a. They are the only constants on two sides. So a is equal to minus 1. A plus b, which is the coefficient of y, will be equal to 0. So b is equal to minus a. That means b is minus 1, which is 1. So our partial fraction becomes a is minus 1. So minus 1 over y. Let me write proper. I will write integration there. So this thing becomes minus 1 over y plus 1 over y plus 1. And now I will use the same here to integrate this. So minus 1 over y dy plus 1 over y plus 1 dy equal to x square minus 2, x to the power minus 2 dx. So integrating this with respect to y will be minus ln y. This will be plus natural log y plus 1 equal to x to the power minus 2 plus 1 over minus 2 plus 1. And we can write c also. So both are natural logs here. We can combine them. Natural log y plus 1 is positive and this is negative, so it divides. Equal to x to the power minus 3 over minus 1 over minus 1 plus c. Now c is unknown and we have been given one situation that when x is 1, y is 1. So we'll find c with the help of this. So ln y is 1, so 1 plus 1 over 1 equal to 1. This minus 1 can become this minus 1, so 1 to the power minus 1 plus c. 2 over 1, so ln 2 equal to minus 1 to the power anything is 1, so minus 1 plus equal to plus c. So c becomes, it goes positive here, 1 plus ln 2. So we got our equation now. It is this one, ln y plus 1 over y equal to minus 1 over x plus c, and c is 1 plus ln 2. 1 plus ln 2. So what is our aim? Our aim is to solve for y in terms of x. That means this y has to be isolated. So what do we do? Let's bring this ln 2 here so that it combines here. So ln y plus 1 over y minus ln 2 equal to, let's write 1 first, 1 over x. Okay, so ln y plus 1, and this is again it is subtracting, so it will divide this one, so it will become 2y here. equal to 1 minus 1 over x. So y plus 1 over 2y becomes e to the power 1 minus 1 over x. But it is still not in term y in terms of x. These two y's have to be together. So we cross multiply here. Y plus 1 equal to 2y e to the power 1 minus 1 over x. Let's complete it further here. So y minus 2y e to the power 1 minus 1 over x, right, equal to minus 1. This one came here, this went there. Okay, so now y can be taken common. 1 minus 2 e to the power 1 minus 1 over x equal to minus 1. So y is minus 1 over 1 minus 2 e to the power 1 minus x. We got y in terms of x, and it was 1 over x, not x. Leaving it like this will not be okay because the numerator is negative. So what I can do, I can make it positive and change their places. 2 e to the power 1 minus 1 over x minus 1. I swap their places because I changed the sign of the numerator. Okay, you could have left like this but doesn't look like. Okay, what next part says? Next part says, state what happens to value of y when x tends to go to infinity, if this goes to infinity. So I can do it here, B part. This x goes to infinity, right? Becomes very, very large. So let's substitute it by infinity. 2 to the power e1 minus 1 over infinity minus 1. Now look, 1 over infinity means very, very large number. 1 divided by very large number will be 0, almost 0, 0.000 something. So we can count it at 0. So it becomes 1 over 2 e to the power 1 minus 0 and minus 1. And we get 2 e minus 1. That's it, because e to the power 1 will be e. This will be the value of y when x goes to infinity. That's the answer. And this concludes the whole exam paper of 32 Pure Math 3 Winter 2023. If you liked it, please give it a thumbs up, share this video with your friends, and subscribe to Math United. I'm going to make many more videos in coming days. Thank you so much.